The Ice Age mystery, the catastrophe that froze Earth for 1,000 years. Close your eyes and imagine. A world where sunlight grows weak, the sky turns dark and gloomy, lush forests vanish, and in their place, ice reigns supreme. Bitterly cold winds slice through the air, the ground is buried beneath miles of ice, and life is reduced to mere traces, struggling against the relentless freeze. Sounds like an apocalyptic scenario? Think again. This was reality, something Earth has endured not just once, but multiple times throughout its billions of years of history. Brutal ice ages have reshaped our planet, wiping out countless species while also paving the way for new chapters of life. What plunged Earth into these deadly frozen periods? Was it an inevitable cycle, or were there mysterious forces at play manipulating the fate of our planet? And more importantly, could another ice age return? Join us on a journey to uncover the coldest secrets of Earth's history and find out what the future might have in store for us. If you love thrilling scientific discoveries and want to stay with us on this adventure, don't forget to hit like, subscribe, and turn on notifications so you won't miss out on what's coming next. Throughout most of its history, Earth has experienced extreme climate shifts. There were times when global temperatures plummeted to record lows, covering vast portions of the planet in ice. Scientists refer to these periods as ice ages. But when was the coldest moment in Earth's history? That question remains unanswered. However, through geological research, scientists have determined that our planet has undergone at least 5 major ice ages and dozens of smaller ones. The earliest is believed to have occurred around 2.4 billion years ago, while the most recent began approximately 2.7 million years ago and, technically, continues to this day. Based on scientific research on climate and geology, you might be surprised to learn that despite witnessing global warming and melting ice caps, Earth is still in an ice age. That's because an ice age isn't just a period when the entire planet is frozen. It also includes alternating cycles of warming and cooling. During colder cycles, ice expands, while in warmer phases, ice retreats. Just as we are seeing today. How do we know that ice ages have occurred in the past? The secrets lie in the traces Earth has left behind, from ancient ice layers and geological records to the fossils of species that either survived or went extinct during glacial periods. These records help us understand that ice ages not only reshape the climate, but also determine the survival of life on Earth. For instance, in recent ice ages, animals such as woolly mammoths, woolly rhinos, and Tasmanian wolves vanished because they couldn't adapt to extreme conditions. Meanwhile, modern humans thrived thanks to their adaptability and ability to develop new survival strategies. But what causes ice ages? And could another one happen in the future? To explore this, we need to examine the factors influencing Earth's climate, from solar activity and changes in Earth's orbit to geological events such as volcanic eruptions and continental shifts. Looking back millions of years, Earth has experienced extreme ice ages where glaciers spread across the planet. At some points, Earth may have been almost entirely covered in ice. The traces left on our planet are like pages of a history book, waiting to be uncovered. Since the 19th century, scientists have found evidence of ancient ice ages. By the 20th century, studies on Earth's orbital cycles further solidified this theory. In North America and Western Australia, sediment layers containing glacial remnants have been discovered in regions that are now arid deserts. In northeastern Europe, fossils of cold-adapted animals have been found in areas that were once close to the equator. But how do we determine where continents were located hundreds of millions of years ago? This is where science becomes fascinating. Every layer of rock on Earth carries a magnetic imprint, like an ancient record. When rock forms, the metal particles inside align with Earth's magnetic field at that time. If the rock formed near the equator, the particles would be positioned horizontally to the surface. About 650 million years ago, the Australian continent, which is in the southern hemisphere today, was once near the equator in the northern hemisphere, but was still covered in ice. This proves that ice ages weren't just polar events, but global phenomena, turning even tropical regions into frozen deserts. These traces don't just tell the story of ice ages. They also reveal how these periods impacted life. As ice expanded, species unable to adapt disappeared forever. But when ice melted, glacial waters carried sediments across the land, creating fertile regions where new life began to flourish. Scientists have discovered that ice ages don't occur randomly. They follow a predictable cycle, and this cycle is linked to something you might not expect: Earth's orbit around the sun. This is known as the Milankovitch cycle, named after Serbian scientist Milutin Milankovic, who proposed this hypothesis in the early 20th century. He discovered that Earth's orbit is not fixed but changes over time. There are periods when Earth orbits the sun in a nearly circular path, but at other times the orbit becomes more elliptical. As Earth's orbit shifts, the amount of sunlight reaching the planet also fluctuates, causing temperature variations, which in turn lead to ice ages lasting tens of thousands of years. Not only the orbit, but also Earth's axial tilt plays a crucial role. This tilt is not constant, but oscillates between 22.1 and 24.5 degrees over a cycle of about 41,000 years. When the tilt is greater, summers in both hemispheres become hotter, causing polar ice to melt more rapidly. However, when the tilt decreases, summers become cooler, leading to less ice melt, and ice sheets begin to expand. Over time, these subtle changes have played a decisive role in determining when an ice age begins and ends. But if ice ages follow a cycle, could we be approaching a new one? This is a major question. According to data from Antarctic ice cores and modern climate studies, Earth is currently in an interglacial period, a warmer phase between ice ages. In the past, such interglacial periods typically lasted around 10,000 to 15,000 years. What's striking is that our current interglacial has already lasted over 11,000 years. So does that mean a new ice age is imminent, or have human activities and their impact on the climate altered this natural cycle? So what could turn Earth into a frozen planet? Scientists have identified three main causes, each a key piece of this massive puzzle. First, Earth's orbit and axial tilt. Scientists believe that Earth does not orbit the sun in a perfectly stable manner. Its axial tilt fluctuates between 22.1 and 24.5 degrees over a 41,000-year cycle. When the tilt changes, the amount of sunlight reaching the poles decreases, allowing ice to form and spread. Additionally, Earth's orbit also varies cyclically, sometimes placing it farther from the sun, which leads to colder, longer winters. Second, the position of continents. Earth is a dynamic geological system with tectonic plates constantly shifting. When continents cluster near the equator, oceans become narrower, reducing their ability to absorb and distribute heat. As a result, ice begins to form, and in a chain reaction, it spreads globally. Once Earth is covered in ice, solar radiation is reflected more intensely, further lowering temperatures. Third and most crucial, atmospheric CO2 levels. CO2 acts as Earth's thermal blanket, trapping heat on the planet. But the snowball Earth hypothesis suggests that a decrease in CO2 levels may have contributed to global ice ages. So how did CO2 disappear? One of the primary mechanisms is the silicate weathering process. Billions of years ago, intense volcanic eruptions released massive amounts of CO2 and methane into the atmosphere. However, when these gases mixed with rainwater, they formed acids that eroded rocks, pulling CO2 into the oceans, where it became locked in limestone. Over time, this gradual reduction in atmospheric CO2 caused Earth's temperature to plummet. But that's not all. A tiny yet crucial factor also played a role: cyanobacteria. These microorganisms perform photosynthesis, absorbing CO2 and releasing oxygen into the atmosphere. Over millions of years, cyanobacteria dramatically altered the composition of the air, weakening the greenhouse effect and pushing Earth into a deep freeze. As a result, Earth remained trapped in ice for over 300 million years. But a critical question arises. If Earth was completely frozen, what eventually ended the Ice Age? The answer is volcanoes. Even though Earth's surface was frozen, geothermal processes deep within the crust continued. Volcanic eruptions released massive amounts of CO2 and greenhouse gases into the atmosphere. Estimates suggest that for the ice to melt, CO2 levels had to be 350 times higher than today. Once CO2 concentrations reached a critical level, the greenhouse effect returned, temperatures began to rise, and the ice gradually melted away. And here's something remarkable. After each ice age, life on Earth rebounded with astonishing force. This proves that no matter how harsh the environment, life never surrenders. It constantly adapts and evolves to survive. However, today we face the opposite problem: climate change and global warming. The CO2 that had been buried for hundreds of millions of years is now being released by human activities, delaying the natural ice age cycle by at least 100,000 years. But what happens next? Today, polar ice is melting at an alarming rate, sea levels are rising, and extreme weather is becoming more frequent. But does this mean Earth will keep warming indefinitely? Or is our planet still undergoing a natural cycle we have yet to fully understand? Climate history may hold the key. Studying past climate changes helps us better predict the future and understand how humans can adapt to and protect our planet. What do you think? Share your thoughts below, and don't forget to like, subscribe, and turn on notifications to continue exploring the wonders of science. Goodbye and see you next time.